So the sensitivity analysis. The project, if we look at it, we can see that it's very sensitive to a price drop or which would directly lead to a revenue drop. So, for example, a 14% drop in revenue would lead to a 6% drop in NPV. So, at so 14% drop is just a $1 billion decrease in revenue, or 14.29% loss of revenue. The NPV would fall from 4.175 to 1.671 billion, or a 59.97% decrease. So for every 1% drop in revenue, there's roughly a 4.2% drop in NPV. So a variation on sensitivity analysis is scenario analysis. So we can, this example, 3 scenarios could apply to Stewart Pharmaceuticals. In the next few years, you can have heavy cold season. Sales could exceed expectations, but labor costs could skyrocket. Next few years could be normal. Sales meet expectations, and then the next few years could have lighter than normal cold seasons. So sales couldn't fail to meet it. So, other scenarios could apply to FDA approval. Each scenario, for each scenario, you're going to calculate the NPV. So, break-even analysis, the common tool for analyzing the relationships between sales volume, profitability. 3 common break-even measures. Counting break-even, so gives you the sales volume at which net income equals 0. Cash break-even, the sales volume at which operating cash flow equals 0. The financial break-even, the sales volume at which net present value equals 0. So break-even analysis. So in the example, we could be concerned with break-even revenue, break-even sales, or break-even price. To find any of them, we need to start with the break-even operating cash flow. So that's simply, we take the $1.6 billion over the 4 years and apply our 10% required rate of return. So we've got $1.6 billion in investment. So in order to break even, we need to generate $504 million each year for 4 years. This is the project's break-even operating cash flow. So on the next sheet, we're going to rebuild the income statement. So we have our income statement set up here. We're assuming our variable costs and fixed costs and depreciation all are unchanged. So our operating cash flow is is going to be our depreciation plus our net income. So that's we see our depreciation is 400 million. So that tells us that our net income has got to be 104 million. So now we can calculate our taxes and EBIT by dividing the net income by 1 minus the tax rate, the 21%. So 104 million, 750,000 divided by 0.79 is 132.59. So, and it tells us our taxes are 27.84 million. And now we can add all our costs, fixed, variable, and depreciation back to our EBIT to come up with our revenue. So break-even revenue is $5.332 billion. So now that we have a break-even revenue, we can calculate the break-even price. So the original plan was generate revenues of $7 billion, so selling $10 per dose, selling $7 million per year. We can reach the break-even revenue. We can reach break-even with a price of only by setting the revenue equal to the 700 million times the price. So that or 5.33 billion divided by 700 million was $70.62 per dose. So that would be our break-even price. So, all right, so next we'll start the next lecture on Monte Carlo simulation.